Ni hao. Last class, we looked at what the antiderivative was, and we did some calculations of general antiderivatives. Sometimes, though, we're going to be looking for particular antiderivatives or specific antiderivatives. So I'm going to show you a couple of examples what I mean by that. So our first example is going to be find f such that f prime of x equals e to the x plus 20 times the quantity 1 plus x squared to the negative 1, and f of 0 equals negative 2. All right. So the first part of this problem looks like something we've done before. Find a function that has a particular derivative, but we're also given another piece of information. Specifically, we want the value of that function at 0 to be equal to negative 2. And this we're going to use later, but this is going to help us figure out exactly what the constant is. Instead of just having a generic constant c, this extra piece of information is going to narrow down what the value of that constant is. All right, let's actually start with finding the antiderivative of this. So we're given the derivative. If we take the antiderivative, that gives us f. Now we can do this term by term. The antiderivative of e to the x is just e to the x. And then we have plus 20 times the antiderivative of this. But remember, 1 plus x squared to the negative first is the same as 1 over 1 plus x squared. And we know the antiderivative of this. This is in our table. The antiderivative of that is inverse tangent. So it's going to be 20 times inverse tangent of x. And then plus some constant. So this is the general antiderivative. But we can figure out what this constant is because we know that the function value when x is 0 should be negative 2. So here's how we can deal with this. If we plug in f of 0, this is going to be e to the 0 plus 20 times inverse tangent of 0 plus a constant. And we know that f of 0, whatever that is, has to equal negative 2. That's what we were given up here. So we plug in 0, see what we get, and set it equal to negative 2, and then we can solve this equation for c. That'll tell us what the value of that constant is. Now e to the 0 is just equal to 1, and then we have plus 20 times the inverse tangent of 0. Well, what angle gives us a tangent of 0? That's actually 0, plus c. So this whole thing is going to go away because anything times 0 is 0. And so we have 1 plus c equals negative 2. And if we subtract 1 from both sides, that tells us that c is negative 3. And so we know that our function is equal to e to the x plus 20 times inverse tangent of x, and then minus 3. Because we know that this constant is equal to negative 3, so we now have the exact antiderivative. We don't have to just say plus a constant at the end, and we don't really know what the constant is. This extra restriction on our function actually allows us to figure out what the value of that constant is. All right, let's look at another one. This one is going to have one more component to it. Let's find f such that the second derivative of f is equal to 12x squared plus 6x minus 4. We also know that f of 0 equals 4, and f of 1 is equal to 1. So here we have the second derivative, and we want to find the function. So we're going to have to antidifferentiate twice, but we also have two extra pieces of information, And those are going to help us figure out the values of the two constants that we get when we go through the process of antidifferentiating. So we're going to first start by antidifferentiating once, and that's going to give us f prime of x. Now the antiderivative of x squared is x cubed over 3. So x cubed over 3, but 12 over 3 is equal to 4. And then we have plus the antiderivative of 6x. We know the antiderivative of x is x squared over 2. And if we take that 6 and divide it by 2, that gives us 3. Right? Because we've got 6, and then we're going to have over 2 from that x. 6 over 2 is 3. And then we've got minus 4x. The derivative of negative 4 is negative 4x plus a constant. And then we can antidifferentiate once more to figure out our function. Let's do that. The antiderivative of x cubed is x to the 4th over 4. And that over 4 cancels with the 4 out front, just leaving us with x to the 4th. Plus, the antiderivative of x squared is x cubed over 3, but that over 3 gets rid of the 3 out front, so we've just got x cubed here, minus the antiderivative of 4x. Well, the antiderivative of x is x squared over 2, and if we take that 4 and put it over 2, that gives us 2. Plus, the antiderivative of c is cx, and then plus we have a d there, because we have antidifferentiated, so we need that constant that goes at the end. Now, this is the general antiderivative, second antiderivative of our original function, but we have 2 extra pieces of information, 2 extra restrictions, and those are going to help us figure out the values of c and d. So I'm going to start with f of 0 equals 4. If we look at f of 0, all of these terms with x's in them are going to be 0, because anything times 0 is 0. And so f of 0 is just d, and we know that that's 4, so that tells us the value of d is equal to 4. So really we can say f of x equals x to the 4th plus x cubed minus 2x squared plus cx plus 4. And then here we can use that other restriction, f of 1 is equal to 1. If we plug in 1 for x, 1 to the 4th is 1, 1 cubed is 1, and then minus, that term's going to be 2, plus c plus 4. And 1 plus 1 is 2, and 2 minus 2 is 0. So all of these cancel, and we end up with c plus 4. And remember, f of 1 was equal to 1. So c plus 4 is equal to 1. And if we subtract 4 from both sides, that gives us c is negative 3, because 1 minus 4 is negative 3. So knowing that, we have our specific value for the function f of x equals x to the 4th plus x cubed minus 2x squared. And then we had plus cx, but we know c is negative 3. So it's going to be minus 3x and plus 4. So that is our answer. Both of these problems required us to take antiderivatives because we were given first and second derivatives and we needed to find the original function. So we were doing antiderivatives, and we know that that usually gives us these constants, but when we have extra pieces of information, we can often use that information to figure out the exact values of the constants and narrow down what our function is going to be.